Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.9, Limits ad Infinity. And to investigate this, we're going to take a look at three separate limits as x approaches infinity. And to do it, all we really need to do is compare the numerator and the denominator of each rational function. You'll notice they're all very similar. You'll notice the only major difference between all three examples is the degree of the numerator and denominator in each situation. Well, let's take a look at the first one. You'll notice the denominator has a degree of 2, and the numerator technically has a degree of 1 up here. And if we compare these, I would classify this situation as something I call a bottom-heavy function. Anytime the degree is larger on the bottom than it is on the top, qualify as a bottom-heavy function, and every single time that this happens, as x approaches infinity, the denominator will be growing significantly faster than the numerator. And when you have a fraction where the denominator is bigger than the numerator, that fraction is going to get smaller and smaller and approach a y value of 0. Hence, your horizontal asymptote will be 0. And the answer to this limit question, every time you have a bottom-heavy function, it will always be 0. Can't stress that enough. If we take a look at this second example, you'll notice the degrees in the numerator and denominator are the same. Now, I like to call this a balanced rational function because the degrees are balanced. And every time this happens, as x approaches infinity, when x gets larger, I'm going to square it in the numerator and I'm going to square it in the denominator. So they're both going to grow at the same rate. So the x squareds are kind of going to cancel each other out, leaving us just with the coefficients. The numerator, if I plugged in 100, it'd be like 40,000. The denominator would be like 20,000. If I plug in something larger, it might be 4 million over 2 million. But in any case, the millions cancel out. I'm just left with 4 over 2 in the long run. So hence, our horizontal asymptote of this would be 4 over 2. Simplify that down to 2. So as x approaches infinity, the limit of this function is going to approach 2. And it will always, always, always end up being the coefficients of the leading terms. Now, these first two scenarios are as straightforward as that. If you have a bottom-heavy function, the limit as x approaches infinity or negative infinity will always be 0. And if you have a balanced function, the limit will always be the coefficients. Now, in this third example, you'll notice the numerator has a larger degree than the denominator, which, not surprisingly, we'll call this a top-heavy function. And as you allow x to grow larger and larger, you'll notice the numerator is going to grow larger and faster than the denominator. And whenever that happens, our number is going to keep growing and growing and growing. Hence, there's not going to be a horizontal asymptote in this situation. But that doesn't mean there's no limit. If there's no horizontal asymptote, that just means my function is going to grow and grow, which means it could grow up to positive infinity, or it could grow down to negative infinity. Hence, this limit will always be one of those two options. In this particular case, since x is approaching positive infinity, we have to imagine what our outputs would be if we plug in larger and larger x values. If I plug in a large positive number in the top and the bottom, and you'll see that the numerator will stay positive and the denominator will stay positive. Hence, as x goes to infinity, my outputs will continue to stay positive and grow, so this would be positive infinity. You have to keep in mind, though, what if this limit is approaching negative infinity? Then we test large negative values of x. And you can see in the numerator, if I plugged in a negative value and cubed it, it would still be negative. In the denominator, I would square it, which would turn it positive. So altogether, this limit would approach negative infinity as x approaches negative infinity. Now, over half of your limits at infinity questions will look like these. So it pays to know this and answer these questions in the most efficient way possible. Be sure to check out our next video that should be popping up right about now, which is a decision tree to help you evaluate any limit you run into. Don't forget to hit subscribe and like the page to get alerts about all the content we release each week.